Hey everyone, today we're taking that classic parabola you see everywhere in algebra and we're going to teach it how to move. We're going to set it free so it can travel all over the coordinate plane. Let's dive right in. So, you know the basic parabola, right? Y equals x squared, you've probably graphed it a million times. And its vertex, that little turning point, is always just sitting there right at the origin, at 0, 0. But have you ever wondered why? Is it just like glued there permanently? No way. The truth is, it's not stuck at all. It's just waiting for us to give it the right instructions. So today, that's exactly what we're going to do. We're going to learn the secret codes to set that parabola free and move it literally anywhere we want. Okay, first things first, let's get our bearings. This right here is our home base, the default plain vanilla parabola, y equals x squared. Its vertex is perfectly happy at the origin. This is the shape we're going to be picking up and moving around. So how are we going to do this? Well, we have two kind of secret codes in our algebra toolkit, the variables k and h. These two little letters are the keys that will unlock all the parabola's movement. All right, let's get into it. We're going to start with the most intuitive, most straightforward move there is, the vertical shift. And this is all controlled by our new best friend, the letter k. The formula is actually super simple. When we take our basic x squared and just add a number, our k, to the outside of that squared term, we're giving the parabola a direct command to slide straight up or straight down. And the great thing about k is that the logic is so simple. It does exactly what you'd expect it to do. If k is a positive number, guess what? The parabola shifts up. And if k is a negative number, it shifts down. See? Totally straightforward. Let's look at a really quick example. Y equals x squared plus 2. You see that plus 2 just hanging out on the end? That's our k value. It's outside, and it's positive. So we just grab the entire parabola and slide it up 2 units. The original vertex from 0, 0 finds its new home at 0, 2. Simple as that. Okay, now that we've totally mastered moving up and down, it's time to meet h and start shifting things left and right. But I need you to pay close attention here, because h has a little trick up its sleeve. Now look at the formula for a horizontal shift. It's g of x equals, and here's the key, the quantity x minus h quantity squared. Do you see the huge difference? The action, the plus or minus h, is happening inside the parentheses with the x, before anything gets squared. And this brings us to the single biggest rule for horizontal shifts, the one thing that trips everybody up at first. You have to burn this phrase into your brain. Inside is opposite. What you see is the opposite of what you do. And this slide shows that weird, counterintuitive rule perfectly. When you see x minus 3 inside those parentheses, every part of your brain wants to move left, towards the negatives. But nope, inside is opposite. It actually moves to the right 3 units. And on the flip side, x plus 3 moves you to the left 3 units. It's wild, I know. Okay, let's walk through y equals x minus 4 squared. That minus sign is trying to trick you. But we know the rule, inside is opposite. So this is a shift to the right. Now here's a great little trick to never get this wrong. Just ask yourself what value for x would make the inside equal to 0. Well, 4 minus 4 is 0. So our shift is to the right by 4, and our new vertex lands at 4, 0. All right, this is where it gets really fun. We've moved it up and down, we've moved it left and right. You know what that means, right? We can now combine those powers and send our parabola absolutely anywhere on the grid. So let's put it all together. Let's find the vertex of y equals x plus 2 squared minus 5. Don't let it intimidate you, just read it piece by piece. First, look inside the parentheses. That plus 2, remember, inside is opposite, tells us to shift left 2. Now look outside. That minus 5 is our k, and it does exactly what it says, shift down 5. So our vertex starts at 0, 0, goes left 2, then down 5, and it lands at its brand new spot, negative 2, negative 5. And here's why all this really matters. This isn't just some random graphing trick. Being able to look at an equation and instantly spot the h and the k is the absolute core skill for understanding something called vertex form. And trust me, that's one of the most powerful tools you'll ever use for parabolas. Now, you might be sitting there thinking, okay, cool for math class, but when am I ever going to see this in real life? I guarantee you've already seen h and k in action thousands of times, especially if you've ever played a video game. Seriously, think about a classic game like Super Mario.
every single time he jumps. That perfect arc he makes through the air, that's not random. It is a precisely calculated, shifted parabola.
And get this, the actual code that runs the game uses an equation that looks exactly like what we've been working with. That x minus 100 part, that's our h. It tells the game the horizontal position where the jump starts. And the plus 50 on the outside, that's our k. It sets the maximum height of the jump. Game developers are literally using h and k to make the game feel just right. How cool is that?
So, there you have it. You now have the power to take a parabola's vertex and place it anywhere you want on the coordinate plane using h and k. But what's next? What happens if we want to change its shape? Stretch it to make it taller and skinnier, or squash it down to make it wider. Or what if we want to flip it completely upside down? Well, that sounds like an adventure for next time.